So in this video we're going to be tackling one of the harder annuity questions, and just to let you know beforehand, I'm going to be using my own calculator for this video because simply because the computer's calculator does not have the exponent function. So feel free to follow along with your own calculators, and let us begin. So a charity decided to invest some money for a lottery they are planning to host. They started depositing $100 every month for 5 years at an interest rate of 5% per annum, compounded monthly. The lottery was held 1 month after the final deposit, and the winner was promised a certain amount of money every month for 3 years, paid for by the money the charity had invested. How much money does the winner receive in total? So first of all, we need to establish some milestones in this question just to keep ourselves sane, because this is a difficult question. So first of all, we know that the charity is depositing $100 every month for 5 years. So we know that the R value, because this is an annuity, as you can see, they are making regular deposits of money. So the R value here would be $100 every month for 5 years, which means that in total, the number of months, or the number of compounding periods you could say, is every month, which is 12 months in 1 year, multiplied by 5. So 12 months multiplied by 5 years is 60. So there are 60 compounding periods in this time frame at an interest rate of 5% per annum. So I is equal to 5% per annum, but we also know that it's compounded monthly, so we have to divide this by 12. So for this question, it would be 0.05, changing to decimals, divided by 12. That would be our interest rate, compounded monthly. So this, right now, this part of the question is all we're going to look at, because this will give us the information needed for the second part of the question. And as most of you have probably realized by now, this part of the question is talking about the amount of an ordinary annuity, while this part of the question, the second part that we haven't looked at yet, is talking about the present value of an ordinary annuity, but we'll get to that later. So right now, we need to decide the amount of money that the charity has at the end of 5 years. So let's write down our formula for the amount of an ordinary annuity first of all. So we know that A, the amount, is equal to R multiplied by 1 plus I to the power of n minus 1 divided by I. So let's input our variables here. So we don't know the amount, that's what we're trying to find. So we know the amount is equal to our value we have over here, $100, is equal to $100 multiplied by 1 plus 0.05 divided by 12 to the power of n. And we established here that n was 60, to the power of 60 minus 1 divided by 0.05 over 12. So I'm just going to simplify this on my calculator here. You guys can follow along with me. So we have 0.05 divided by 12 plus 1 power of 60 minus 1 whole thing divided by 0.05 over 12 equals $68 multiplied by 100 would be, so multiplied by 100 would be $6,800.61. So that is the amount of money the charity has at the end of 5 years. Now let's look at the second part of the question. The lottery was held 1 month after the final deposit, and the winner was promised a certain amount of money every month for 3 years, paid for the money the charity had invested. How much money does the winner receive in total? So this is talking about the present value of an ordinary annuity, because we can see that there are regular withdrawals made from an account at regular intervals of time. So let's write down, actually first of all, I'm going to copy this formula over so we have more space. So just copy that over. Let's move down here. Perfect. So first of all, let's write down our formula for the present value of an annuity. So we have present value is equal to the monthly payment or withdrawal, in this case it's a withdrawal, multiplied by 1 minus 1 plus I to the power of negative n divided by I. So again, let's input our known values here, and in this case we know what the present value is because the present value is the same as the amount, because this is what the charity has at the beginning of the time they start making withdrawals from the account. So we're going to input the value of $6,800.61 for our present value. So we have 6,800.61 is equal to, we do not know R here. We don't know how much, what's the monthly withdrawal that the charity is making. So we're going to leave that as R, multiplied by 1 minus 1 plus 0.05 over 12. The I value and the I value here remains the same because the bank account still has the same interest rate of 5% per annum. So we're going to leave that as 0.05 over 12 to the power of negative n. However, here the n value has changed because now the time frame here is 3 years every month. So we know that there are 12 months in a year and they're asking us for 3 years. So the n value here would be 36 to the power of negative 36 divided by I, which is again 0.05 over 12. So let's solve for R over here this time. So you guys can again follow along with me. I'm going to do this on my own calculator. So 0.05 divided by 12 plus 1, subtracted by 1, to the power of negative 36 divided by 0.05 over 12, and the whole thing divided by $6,800.61 gives me a total R value of $203.82. So that is our R value over here, which means that this is the monthly payment that the winner of the lottery is receiving. So however, the question here, as you can clearly see, is how much money does the winner receive in total? So we know that the monthly payment that the winner receives is $203.82, and we also know that he or she receives this amount every month for 3 years. So 12 months multiplied by 3 years, which as we established was 36. So he receives this amount 36 times, which means to find the total amount, so we'll label that TA, total amount, we simply have to multiply the monthly amount that the winner receives by 36 because he's receiving it 36 times, and this gives me a value of 203.82, that should be 0.82 times 36 is equal to $7,337.52. So in total, the winner of this lottery receives $7,337.52. And there you go, you just solved one of the most complicated problems in this unit. So give yourself a pat on the back, and we'll see you next time on one of our other videos.